know that you are able to see it.
Yes, you're ready.
Excellent. All right. So let's see if I do slideshow. Am I still presenting?
Yes, full screen.
Perfect. Beautiful. Beautiful. All right. All right, folks. Today's focus basically is to get you guys as much time as possible to get some hands-on. So it's a workshop today, but I'll definitely share some slides to set the context, to give you some high-level background and an overview of the solution, so that when you start getting into the workshop or getting on the hands-on section, you're not completely lost and you have some context of what you will be doing and what some of the features and capabilities are of Consul. At a very high level, here's a brief agenda. We'll have, kind of describe some of the components of a Consul from an overview standpoint, go into some level of, very brief networking journey to a certain degree, some use cases of Consul and Consul architecture, and then we'll split into split the labs into two sections. Section one of the labs will be focused on Consul basics and the service discovery piece. And then we'll come back into the main room here before we split again for the last lab, which is the mesh, Consul mesh lab. So Kelly, if you can tee up the poll here. So first, before we get started, we want to make sure that everybody's ready and active, and we love active participation in these events. So here's a question, first poll of the day. Are you using any HashiCorp products in production? Answers are Terraform, Vault, Consul, Boundary, and there may be some of the products which are not listed here, but we want to figure out what do you guys have running, and more than one response is perfectly fine. So those of you guys who don't know, Terraform obviously is our infrastructure automation tool. Boundary is the newest member in the family here. And the results, all right, so 80% of participants have Terraform in production, and 33% in Vault, Consul, and 3% Boundary, which is very nice. Excellent, thank you. All right, so let's get into the meat of the workshop details here. So the workshop itself is built upon a platform called Instruct, which makes our life easier both in terms of accessing it, configuring it, setting it up. So every individual on the call here will receive their own pod per se. So you will have your own account that you can log into and create the login for Instruct, and you're able to work through your own workshop. So your own kind of a sandbox environment to do your things, right? And Instruct basically only requires you to have just a laptop and some sort of internet connection and with a browser. And we'll give you details on the links themselves. But one thing I want to highlight is that the objective of the workshop is not to get you guys ready for a full enterprise Consul installation or usage. This is just to give you a foundational level of understanding. Because there are a lot of shortcuts that we use. For example, Consul requires you to have X number of servers. Most of the labs you will see we'll just have one server hosting that. So there are some shortcuts that we've taken throughout the lab. Again, not to be construed as a full tutorial here. This is just to get your feet wet in Consul and give you a good level of understanding. And from a requirement standpoint, some level of compute, network, DevOps background is good, but not necessary. All right, so before we get into Consul, one of the fundamental things that we kind of want to talk about is this notion of zero trust. Now, I know zero trust is kind of a loaded term. It's a marketing buzzword, but we believe that zero trust has to mean something, some amount of tangible items we should be able to checkbox off of, right? First and foremost in that vein of thoughts is we want to make sure that every piece of communication that is happening between humans and machines or machines to machines has to be identity driven. And what I mean by that is that we want to make sure that the identity of a service or a human has to be decoupled from where that machine or human is logging in from, the location, the cloud, the IP address. So basically decoupling the IP to the service itself. Right? That is the first step of bringing an identity-driven approach. So once we have this universal identity that survives across multiple boundaries and is common across different clouds, now we can use that identity to create a bunch of different things. For example, I can put security policies. I want to make sure that I have mutual authentication using that identity. That identity could be driven by a certificate, for example. And then we want to make sure that everything is authorized, all communications, right? If service A can talk to service B, is it allowed? Do you allow service A to talk to service B? That's some sort of an ACL policy mechanism, right? And in terms of ACLs, in terms of rules, policies, keys, certificates, they all have to be time bound. We don't want certificates that last forever. So we have to have a mechanism to kind of control your JOT tokens, your passwords, your keys, etc., to a time bound mechanism, right? And then we believe that data has to be encrypted, whether it's in rest or in motion, and how do you provide for that, right? So these are some of the fundamental principles, and Consul actually enables all these things within an organization. And last but not least, obviously, we believe everything has to be audited and logged for forensics purposes, right? And these policies have to be applied across the board for human-to-machine access and machine-to-machine communications, right? At a very high level, what is Consul? Consul is essentially an API-driven secure service network solution, right? And what is key with Consul is it's actually platform and cloud agnostic. So you can run Consul, the same binary, the same configuration parameters can be leveraged across multiple clouds. It's literally cloud and runtime agnostic. A lot of the solutions in the market that we see are, either kube focused or container focused or VM focused. We at HashiCorp taken an approach where we decouple ourselves from the actual technologies themselves that are running, right? We want to make sure that whatever we bring to the market can be pervasive across multiple different clouds, environments, etc. So a brief history. Now, I just have a couple of slides here. I'm just going to go at a very high level, right? I'm not going to give you a networking one-on-one lesson here. But traditionally, what we have seen is this journey from a client-server model where, an application might be deployed in a monolith model. Maybe it's tied to a single bare metal server. And in the 90s, we saw this journey where we started to adopt hypervisor technologies, basically splitting up that monolith and kind of making it more efficient to a certain degree by being able to run multiple monoliths inside a single physical hardware, right? And all this communication was kind of traversing through a set of firewalls and networks. So networking and firewalling didn't make a lot of change. To solve for that, we saw this journey where a company started to adopt software-defined networking, right? The whole notion that can I automate and can I program my network infrastructure in a software-defined model where I can simplify it. But clearly, as you see, during this journey to modernizing our networks and applications, we have added a lot more complexity. It hasn't become any more simpler as we transition through the years of evolution within our compute journey, right? And we still have the problem of solving the applications themselves. So these monoliths, we started to break them apart for multiple reasons, obviously. So containers came into play because you're able to scale them independently. You can have a lot more agility built in from a developer standpoint. You don't have a lot of dependencies. Upgrades became easier. So containerization took hold, which created a new conundrum from a network standpoint. Now, how do you have communications patterns between multiple containers that are running on the same cluster, that might be running on the same node themselves, right? Security and load balancing became challenging, right? And when you add to this the notion of public cloud elements, multiple different variants of how containerized workloads work, whether you have Cube, whether you have OpenShift, you might have Rancher, you might have other things running, bare metal. And this became really complicated, right? We sometimes call it the problem of fragmentation. on how do you bridge between a network that can solve for all these problems, right? So this is where kind of we bring Consul into the picture, right? Another way to look at networking is from a traffic pattern standpoint, right? There are generally we define traffic pattern in a north-south direction and an east-west direction, east-west being within the data center between our application tiers, right? In the early 90s, if you recall, we would talk about north-south being, hey, 80% of traffic actually lives east-west, only 20% goes outside the network. Now we have seen that has completely flipped. Lately, what we see is 80% of the traffic is actually east-west within the data center, and very small portion of the total traffic is actually north-south. So this creates a new conundrum, right? How do you manage east-west traffic between our application tiers? How do you secure them? How do you put layer 4, 7 through 7 security and policies across that, right? And then when you scale these applications, now you have to think about, okay, how do I modify that firewall rule when a new instance of my API comes up, right? Or a new instance of my web server comes up, right? So we kind of generally bulk these items into like 3 or 4 buckets, right? Firewalls, we kind of say that they are kind of your authorization element that control traffic flow, right? Load balancers are generally provide the function of naming to a certain degree, and some traffic management where you can say 10% of traffic should go to this, 20% should go to this version, right, etc. And then APIs obviously for your ingress and route filtering, right? A lot of the times we see APIs kind of implemented from a north-south direction, right? And then from an authentication standpoint, we kind of think about how are we creating that authentication parameter, right? Generally, we kind of divide our networks into VLANs or subnets to provide some level of an identity based blockade, right? Kind of a grouping of objects based on VLANs or identity, right? So these are the 4 kind of parameters that we generally we talk about, right? From a network basic standpoint. And as you can see, there's a ton of problems that we need to solve from a network standpoint. You know, we have the problem of a perimeter that is porous now. You know, back in the day when you had a castle and moat approach where you have a brick wall built around your data center versus a cloud, which you have no control over, your IPs are ephemeral, right? How do you link these things, right? You have to solve the problem of data traffic between multiple different clouds. How do you tackle the problem of identity management between, you know, on-prem to cloud, etc. So there's a lot of things that we need to solve. And Consul kind of eliminates and solves a lot of these issues that I'm describing here. All right, Kelly, I think we're ready for poll number 2, since we're talking about data centers and networks. So here's a question. How many different types of data centers does your company support? Is it you know, do you guys have a single data center, whether it's public or private? Do you have hybrid data centers? So more than one, and one private and one public. Multi-cloud, more than 2, right? Multiple private data centers, so 2 private data centers perhaps, and multi-hybrid, so obviously multiple cloud and multiple private data centers. How are we looking at collecting the responses?
Got about 22 here. Give it another second or 2, and then I'll end and share.
Yeah, absolutely. I mean, I think we are seeing a lot more customers with, you know, either B or E, where, you know, they are not completely in public cloud, and they have multiple data centers, whether, you know, a combination of public and private. So this would be interesting to see what the audience here has.
There we go. I'll just end that one right there, and let me share it for you.
All right, so 60% of the participants actually are on a multi-hybrid cloud. So that's pretty interesting. So this creates a problem, right? When you have a data center situation like this, how do you bridge between multiple clouds? How do you create a uniform identity across these multiple locations? So this is where I'm going to get into Consul Enterprise, right? So Consul has really 3 use cases at a very high level. Consul creates this notion of a global service registry, which allows you to register services, and now other services can discover them. And there is a health check aspect of it as well. So if you're not talking, please mute yourself. Thank you. So, and this, one of the two fundamental elements that come out of the global service registry is one is the ability for us to create a service-to-service communication pattern, which is sometimes called ServiceMesh. And in some literature, you will see that says Consul Connect. And then the second piece is the ability for us to automate network infrastructure. So if you have a load balancer or a firewall, can we make config changes to those elements using this global registry? All right, so when we talk about the global registry, Consul is kind of a client-server model, right? Here, what I'm describing to you in this magenta box is a notion of a Consul data center, which contains a set of servers. Here, in this case, we have 3 Consul servers. There is a single binary that runs to create the server. And within these servers, you would have one of them become the leader. There's a leader election happens using an internal protocol called Raft. And leaders would have the capability or the responsibility of doing both write and read. And the followers bring the capability of read. So if a request comes and the followers can just respond to it, but if there's a write request or there's change in, for example, a service's health or services entry, the leader would write it and commit it to the system. And how we accomplish this is using an agent. And the same binary, it's a binary written in Go that actually lives along with the service. So in the screen here on the white box, that white box could be a VM, it could be a container, it could be a bare metal server, it doesn't really matter. Consul's binary, we can run it on, like I said, multiple different platforms. So this Consul binary that sits along with the service actually does the registration. So it will make a call onto the service registry and register the service. So imagine a scenario where you have more than one service that comes up, right? So Consul is able to register those. Now, if A needs to talk to B, A can just call the name of the service B. It doesn't need to know how many instances are there. It doesn't need to know where it is located, what cloud it is on, what IP it has. The application A itself just calls it by the destination or upstream service name, and Consul will provide that resolution of the healthy instances, because we do a health check as well. So the agent does a health check not only on the system itself, it does a couple more things. It does a health check of the service and also the network. So it cross-checks amongst each other to see are the sister services nearby are up and running. And the way it communicates to the service registry is one of 2 ways. Obviously, you can use a REST API. Like I mentioned earlier, Consul is a REST API-driven infrastructure, but a lot of the applications natively understand DNS, so we allow for that communication as well. So the agent can request the local, the service can request the local agent from a DNS query standpoint. It will give you the destination of the service itself. Now, the service mesh aspect of it, now one component we add with service mesh here is when service A needs to talk to service B, we program using Consul's agent that is living along with the service, a proxy. And now what happens is that instead of A directly communicating to B, it actually uses that proxy as a mechanism to communicate. Think of the proxy as a data plane. So A doesn't know where B is. It doesn't need to know. It just needs to know that, hey, I need to talk to B. And the proxy will interface that traffic. And now proxy will make that mutual communication happen between the 2 agents themselves. And obviously, like I said, there are a couple of other parameters. I have one more slide later on. I'll kind of dig deeper into it on the service mesh aspect of it. But at a high level, we are able to encrypt traffic and do some policy configuration, et cetera here. Now, if you really look at the config itself, now this is the same config that will live on, it doesn't matter what platform you're running, right? Here I'm describing a service A, and I'm saying the service A is actually listening on port 9090. And then the 4th line here, which is the connect parameter, this is what brings that Consul service mesh element to it. Now I'm able to do some creative things. I can say where my upstream is. My upstream is called service B, but guess what? That service B that is an upstream, it's actually locally available on port 8003. So when service A needs to talk to service B, it doesn't have to look at the network at all. It doesn't have to put the packet on the traditional wire. It just has to make a local call on its own local host on a local port. And the proxy now, or the connect service, will carry that traffic to the destination. So the service is nonetheless wiser that it's talking to an upstream that is sitting across the pond on a different cluster, on a different cloud, etc. It doesn't matter where it is, right? The proxy manages that connection. Now, when we talk about proxies, it could get really complicated when you have thousands of services talking to each other. Obviously, I kind of described that proxy to proxy communication happens whenever we are trying to create a service mesh, right? So it might look something like this. Now, this creates a problem. Often it's not possible to open ports, especially on a public cloud, and you might not even have the control of the IP address, right, to be able to do this. And this creates a messy network pattern. So we need to be able to solve for this, right? But before I get to that, I want to describe one other element, which I probably glanced over, right? I mentioned that the magenta box is actually a Consul data center. So a Consul data center is defined as a set of servers and the corresponding client agents that are communicating with each other, right? So DC1 in this case, on the left side, is a Consul data center. A Consul data center could run in a single cloud region. It could run on a single kube cluster. The boundary of a Consul cluster is really defined by the reachability, how far the agents are from the server. We generally recommend that as long as you have a 10 millisecond radius, you can build a Consul data center. So for example, you wouldn't span a Consul data center between two regions. You would be able to span a Consul data center within a single region in multiple availability zones, right? Or a single physical data center, right? We do have examples where customers have spanned it more than that, but generally the recommendation is 10 millisecond round trip latency on where you want a Consul data center to be. So going back to the problem I was describing earlier, from a connectivity standpoint, how do we solve this? We have something called the mesh gateway that we bring into the picture here. So mesh gateway basically bridges the connection between data center. So now we have a couple of things, right? As long as I have an external IP address for the mesh gateways to talk to each other, I can actually have overlapping configuration IPs on my data center. For example, on the left side, I may be running on a kube cluster that is running an RFC 1918 address, and the same thing on the right side. So overlapping IPs, how do you solve that? Traditionally, networking is very difficult. You have to do dual NAT and all sorts of crazy heroics to solve this. Consul ServiceMesh does it elegantly because we don't really care about the IP. We just route based on the service name. So if service A needs to talk to service D on a different data center, no problem. We'll route it through the mesh gateway. And one other thing is, I mentioned that all proxy to proxy communication happens in fully encrypted, mutually TLS encrypted traffic. So in this case, when A talks to D, we don't break the TLS session. So A still has a single TLS session, and that is something that is pretty impressive on what the mesh gateway does. Without really opening the packet or decrypting the packet, I am able to establish an end-to-end connectivity. I am able to route the packet through the mesh gateway to whatever the destination is without looking into the packet. Now again, from a networking standpoint, a very difficult problem to solve, but we are not using IP for networking here. We are using something called SPIFFE IDs based on a TLS certificate that is assigned to every single service. So very efficient way of kind of connecting data centers, kind of to have service-to-service communication across multiple different locations. So from an enterprise architecture standpoint, like I briefly mentioned, right, Consul data center is described as a set of servers and a handful of clients. So in this case, I have, and usually you will have an odd number of servers. Here I'm describing to you 5 servers. And the reason why we want to have odd number of servers is so that we don't have a split brain condition in case there is a failure that happens, right? So we always want to make sure that there is a majority of the nodes available for Consul to work properly. So in this case, let's say 5 nodes are there. There's a leader election that happens. And once this leader election happens, it will pick one leader. And let's say that leader fails, right? No problem. We still have 4 out of 5 servers in place. We will have another leader election and another leader is picked up. Let's say one more node fails, still no problem. We still have the majority. We still have 3 servers out of the 5. Now, if one more node fails, this is where we get into a situation where we have to restore at least one node from a snapshot or from a backup, right? So this is architecture at a very high level on how Raft consensus happens. And if you really want to learn more about the whole Raft algorithm and the failure scenario, there's a link that I have in this document. And by the way, we'll share this document with you guys as well, so you can have a copy of all these slides as well. Now, one slide I want to talk about is regarding Kubernetes, right? So Consul, in terms of Consul, Kube is a first-class citizen. And I kind of briefly described some elements of how we do mesh gateways to kind of bridge overlapping IP addresses. Now, this solves a lot of issues, not just in Kube, other places as well. But the way we deploy Consul is you can deploy Consul inside a Kube cluster as a stateful set, right? Or you can deploy it outside. And you can link multiple Kube clusters to a single logical Consul cluster. So you might have multiple different tenants, each with its own Kube cluster. We can kind of piggyback all of them using a single Consul cluster as well. And from a deployment standpoint, we make it very easy to deploy Consul onto Kube using a Helm chart. We provide a Helm chart with a bunch of values that you can edit and customize to deploy it, right? And from a management standpoint, we have custom resource definitions that we allow. So you can, you don't have to really go out of the way to configure things for a developer, for example, to make an application work within Consul. All they need to do is add some annotations. Here, for example, at the bottom here, I have these 2 annotations that I've added here, which allows for me to add the sidecar into that pod. So the way we stand up the servers themselves, like I said, is stateful set, but then there's a daemon set that we install, which allows for us to do creative things like this. We can inject a sidecar along with every pod. And then, so at the end of the day, what I'm trying to describe here is that from a developer workflow standpoint, it makes it very simple for them, right? They don't have to worry about the underlying networking, the security aspects, all that is kind of taken away. So all the technical debt that they would have to worry about is kind of removed, because they can use a simple YAML manifest that they are used to when deploying applications. All right, so service discovery and network automation. So we kind of went through this, high level, right? Firewalls, the role really is authentication. Load balancer, we kind of talked about naming and traffic management, right? APIs for ingress and route filtering, and authentication and identity based on, traditionally an IP or subnet kind of based on role. Now, from a registry standpoint, traditionally, if you think about it, right, if service A needs to talk to service B, it has to go through, it has to call a DNS and look up the name, b.corp.local, and it has to go through the, perhaps a firewall load balancing. The load balancer provides the naming functionality, and that DNS mapping is something that has to be done manually. When we bring Consul to the picture, now we can kind of remove all that burden. Instead of relying upon DNS that is static, now we bring the notion of a dynamic architecture where the agent itself will provide, hey, we'll look at the health instances, we'll make sure how many instances are running, the healthy or not healthy nodes will be taken down based on the health status, we'll do reachability, and now we're going to give you exactly the active members that you need to reach. So service A, for example, can now also do load balancing, right? If you think about it, it says, hey, I only have 2 destinations or 2 upstreams, and it will round robin load balances. So to a certain degree, I can remove the load balancing function from a traditional load balancer and hand it off to Consul. From a network automation standpoint, similar story, right? We have something called Consul Terraform Sync what CTS does, which is this purplish box in the middle, it subscribes to a service. It says, hey, I need to program my firewalls and load balancers based on the change that is happening on a service. A service instance changes, the health status changes, or it scales up or scales down. How do I automate my firewalls and load balancer based on this information? So CTS is able to subscribe to that service. And whenever there's a change that happens, CTS will kick off a Terraform run, which will make the modification necessary for the firewall. So, if it needs to add an IP address or remove an IP address from a pool, it will do that. So this is the NIA piece of it. So Consul is able to do the network infrastructure automation using this kind of a mechanism. All right, so it's kind of time for our breakout here. I wanted to, and I know I'm rushing it a little bit because I want to give you as much time as possible. So here we'll be doing 2 lab exercises. One will be the Consul Enterprise Basics and the Service Discovery with Consul. And during these, you will have, at least in the first lab, you'll have 3 Consul nodes. You will do kind of a failure test. And then you'll try to run an application here. I think there's a WordPress application that you try to break, that you try to fix is probably broken there, and kind of shows you some of the DNS integration piece as well. So before we break out into the rooms, I want to post the link of the lab itself and walk you through really quickly. So let's see. All right, so let's see, where's my chat window? Oh, somebody's already posted it. So this is the instruct link. So once you click on that link, it will take you to a login page. So if you have not logged in to instruct first, just create a account and then log back in. You may have to refresh it. And then once you do that, you'll have to click on add to my study room. And once you add the lessons to your study room, let me share my entire screen here. Okay. Once you add the lessons to your study room like this, you will see that you will have 3 new tabs: Service Discovery with Consul, Consul Basics, and ServiceMesh. So in the next 40 minutes, we will do Consul Basics lab and the Service Discovery with Consul lab. So with that, Kelly, I think we can get people into breakouts.
Perfect. The first room I've got set for 40 minutes. And there you are.
All right. And what I was going to do we have more people? Let me just let's try it one more time. So tell me if you guys are you guys able to see my screen now properly?
Yes.
All right, thank you. So Kelly, as we have come back from the break here and the lab, let's throw another poll out. So this is around ServiceMesh. And the bigger question is, what do you guys want to do with the ServiceMesh, right? You're new, you have never heard of ServiceMesh. You want to implement some of the zero trust principles that we talked about, which allows you to, stretch your policies across multiple runtimes and clouds. You want to use ServiceMesh to accelerate an application delivery for developers and kind of remove the technical debt, in terms of not worrying about security and networking principles. And you want to automate, the certificate lifecycle for all control planes. One of the things that we do with ServiceMesh is create this control plane with service certificates, support geo failover, layer 4 through 7 routing, network segmentations. What are those? So, and obviously it's a multiple choice. We'll give it maybe a minute or so for this, because there's a lot more reading to do here.
Got about 47% of folks who responded, and it's a race to the finish here. Awesome. All right, I'm going to go ahead and end it and share out those results.
Yeah, I'm kind of excited to know what this is going to be. All right, look at that. Oh wow, 50% don't know what ServiceMesh is. So this section is going to cover ServiceMesh. Now I'll kind of take my time here a little bit because I was hurrying through the first half. And let's see, zero trust principles, obviously, yep. So a good mix of all the other answers, around 25% each, 22, 23% each. All right, cool. All right, let's talk about ServiceMesh for a minute here. Again, a recap in terms of the network basics, right? We understand authorization for firewalls, and you've seen this slide now, I guess the third time, so I'll skip all that. All right, so from a ServiceMesh standpoint, I briefly glanced over what this meant in the first section. So what we bring to the table when we talk about ServiceMesh is not just the service registry element, but using the service registry as a mechanism to provide network connectivity. So in this example, you have service A that needs to talk to service B. Right? These could be, the white boxes could be, like I said, a Docker container. It could be running on completely two different clouds, two different platforms. It doesn't really matter. A needs to talk to B. And now we introduce another item into the mixture called a proxy. So that proxy here that we are describing is what we call Envoy proxy. So Envoy is an open source proxy. You could use multiple different proxies, but we support Envoy because Envoy is generally known as the king of all the proxies. So what happens is that Consul will bootstrap the proxy. There's a config that we generate. So the proxy comes up, we configure that proxy, and we put some more instructions into the proxy, which allows us to do some creative things. So instead of having A directly start a communication with B, now we can kind of enforce the traffic to go through the proxy, both coming into service A and going out of service A. So we have some capabilities where we say, okay, if A needs to talk to B, it has to talk to the local proxy. And that and if you think about it from A standpoint, A doesn't really need to worry about where B is, what the IP address is, what is this, which cloud it is, how far it is. All that can be done by proxy. So the communication really is essentially between the proxies. So A thinks it's talking to B, but A is really talking to the local host on its own host, an open port that the proxy is listening to. So let's talk about some of the advantages and why you want to do this whole proxy thing. Why do you want this whole service mesh, right? So first and foremost, we want to make sure that we bring in some of those security principles that we talked earlier. So when Consul registers a service and you enable the proxy function, every single service receives an identity from Consul in a certificate format. So every instance has a unique certificate that Consul generates because Consul has a built-in CA, a certificate authority. You can also use an external CA like Vault to augment the CA functionality. So if you as a customer is using Vault, and we kind of recommend that in production, you want to use Vault as the backend CA. So the CA will provide the certificate, which is unique to every single service. So now when service A presents itself for a communication to service B through the proxies can mutually authenticate using these certificates. So it's essentially you are able to cover this notion of a mutual TLS between the two services. So now that we have established the identity, because within that certificate, there is an identity parameter, something called spiffy identity, which is built into the certificate. So using that identity, we have kind of authenticated, but the question becomes, is A allowed to talk to B? What about the authorization piece? This is where we introduce something called intentions. So Consul has the notion of kind of ACLs where you can dictate and say A can talk to B and B cannot talk to C. And this is a global intention. So it doesn't matter how many instances of B are running, or where they are running, or how often they come back up or go down. You only need to create one single rule. It says B is not allowed to talk to C, and it doesn't matter where they are running again. We will enforce that through the proxy. So the proxy gets configured with this ACL. So in this case, A is allowed to talk to B, so communication is allowed. So that's how we solve the authorization and authentication pieces, right? And the fact that we are using TLS certificates, and we have this mutual TLS between the proxies, that automatically lends itself to encryption. So all communication between service A and service B is now encrypted. So this is fundamentally the principle of ServiceMesh at a kind of a high level on what you're really solving for, bringing those security principles, making sure that there is end-to-end secure connectivity between services, and services don't have to worry about the security elements or where they are located, the IPs, networking pieces, etc. So removing the technical debt of a developer who wrote that service. All he needs to do is call the destination service by its name, and the rest is taken care of by Consul Service Registry and the Consul Connect or the ServiceMesh itself. All right, something else that we bring to the table as part of a service registry is this notion of kind of a canary deployment or a blue-green deployment. Think of this as a mechanism to load balance your service. Let's say if the developer wants to build a new version of this service B, and he only wants to send 10% of his traffic to B so he can test that application or test the new version, you can program Consul to do that. You can say, okay, 10% of this traffic should go to a meta tag called V2. And using that tag, we will just make sure that only 10% of traffic goes to the new version. Once the developer feels comfortable that his application is good and healthy, then we can shift to the all of the traffic to the new version. So kind of a smoother deployment model. So load balancing using waiting is one way of solving it. You can also use other mechanisms of load balancing. For example, a URI filter, right? There are other things that we can do from a service mesh standpoint, in addition to load balancing as well, that provides a higher level of developer functionality. And I'm not going to go into all the details here because of lack of time. All right. Something else to notice here is developers want to have two other pieces of information. One is metrics and telemetry. So here what we are able to do is using Prometheus, so Consul has a built-in capability to communicate directly with Prometheus backend, and you can ingest the data into Grafana for a dashboard, and you can also tie that back into the UI itself. So here, as you can see, I can look at my failure rate, how many minutes per second, the data flow, how many error ratio. I mean, all these typical things that a developer and a network team would want to see, you can do that. Second thing that we do is tracing. So if you have an application that has multiple tiers, that has to go through, let's say, an API gateway, a backend, a product, multiple different hops within the application tier, we can provide tracing of that application. So we can say from the front end to the API, it took 20 milliseconds. From there to the backend database, it took 30 milliseconds. So we can really trace the traffic using Consul because we expose that through the Envoy proxy. So a couple more slides here on the mesh gateway capabilities, right? So obviously we briefly glanced over the functionality that you can have multiple data centers that are linked to each other. In this scenario, let's say we have two kube clusters on my left on-prem data center. A and B are the services that are running on it. If service B that is an upstream for A completely bombs out, or that whole cluster disappears, Consul has the intelligence to know that instance of B is also running on a remote data center. So I have B running on AWS or Azure or GKE somewhere. Consul will automatically route that traffic through the mesh gateway to the remote destination on where B is running, to the healthy instances of B. And the reverse is also true. If B needs to talk to something or a service that doesn't exist locally, it will then connect to the remote service. By default, Consul makes sure that the services that are local will be the one that will be presented first. So as long as there is no local service available, that's when you will, it will connect you to a remote service. So that's the functionality of the mesh gateways. So understand that within Consul's data center, we want to make sure that if you want to use ServiceMesh, you have to have the TLS aspect of it. So you have to have a certificate authority that Consul provides to build those certificates. So every communication between any proxy is based on that certificate. So in certain instances where you have no control over that, where you have, let's say, something that needs to access a service from the Consul service mesh, and you have no control, like a .NET app, and you cannot install an agent here or install the proxy, how do you bring this communication into the service mesh? How do you allow that ingress to happen, right? Because we don't have certificate that's valid. This is where we bring something called an ingress gateway. So ingress gateway kind of is the bridge which translates between untrusted or services that are outside of Consul's mesh control plane and brings it into the control plane. Similarly, if you have access that needs to come outside, for example, a serverless or a user that needs to access something of a service internally, you would use an ingress gateway. And we typically want to make sure that the ingress gateway is front-ended with a web application firewall of some sort. There is also another element called the API gateway that we have in place. So it's a modified version of the ingress gateway, which allows you to do additional functions, for example, external TLS authentication as well. So ingress gateways basically allow you to bring traffic in to the service mesh that are not mesh capable or that are not mesh ready. The reverse mechanism is also true. So let's say if you want to access something that is not inside Consul's control plane, an external service or a hosted database, for example, how would you reach out to the database that is running on a public cloud, for example? Here we can use what's called a terminating gateway. So terminating gateway will terminate the connection, and then it will establish a new session to wherever that destination is, using whatever protocol that it allows for communication, whether it's TLS, HTTP, MTLS, etc. And this is how we bridge communication to entities that are not part of Consul service mesh. All right, so that was a slide those are the slides that I really had. So in this next lab here, which I believe is another 20 minutes or so, we will be going into the Consul service mesh piece of it from deploying the sidecar, looking at the Envoy proxy. So some of those constructs that I just talked about, we're going to be playing around with those. All right, so Kelly, if you can open the breakout rooms again, we can have people filter back into those rooms. All right, welcome back. Kelly, I think we have closed out all the breakout rooms, right?
That's correct, yes.
Yeah, thank you. There's a couple more slides to just, before we do the slides, I want to get the last poll of the day here. So now that you understand service mesh, what are your biggest concerns adopting a service mesh? Clearly the fact that it's still, new to the concept of service mesh, some of the things that we already talked about, adding complexity and time to application delivery, supporting multiple runtimes, platforms, and clouds, discovering and tracking services and service health at a global level, observability and troubleshooting, maintainability.
The bars are shifting. Give me a few seconds. We'll let folks answer and then I'll share them out.
Okay, yeah, this is also a tough one. The question is like, what are the biggest concerns? I go, I don't have any concerns. I'm good. I want to install Consul now.
All right. Looks like we've got most of you, so I'm going to go ahead and end this and share it out.
All right. So we have a mix here, maintainability, adding complexity and time to application delivery. Yeah, there's a mix here. So that would be interesting to know, some of the details as well. I feel like Consul, although it adds another component to the mixture, but it really solves a lot of the traditional headaches that developers and IT teams have had to manage, right? So what we covered today is basically three things, at a high level. We understood the service discovery portion of it, how Consul registers services. And we also learned about how we use that service to do a couple of things. One is network infrastructure automation. We did not have a lab for this today, but there is a lab on May 19th on this second line item here. So on May 19th, if you mark your calendars, and I'll post a link to this workshop on your chat window, we will do a network infrastructure automation workshop. But instead of that, you did use the service discovery and service registry component to do a Consul template update. And finally, you guys also did the ServiceMesh, right? Let's see. So at a very high level, kind of recap everything, what Consul really does is brings this notion of a secure zero trust networking capability across the board for all your services without prejudice to where the services are running. So you could run the service on-prem, on a VM, on bare metal, in the cloud, ECS, Fargate, it doesn't really matter. We can bring all these security policies and we can stretch your reach of service-to-service capability and communication securely across multiple different locations, right? That is what Consul Connect really provides. Next steps, there is a bunch of Learn modules that you guys can follow and go through at learn.hashicorp.com. There are individual guides that actually go into specific features. If you want to learn more about Consul's integration with Cube, you can learn that. If you want to understand how we integrate with Prometheus, there's a bunch of labs, kind of self-guided labs that you can walk through. So we highly recommend to enable your learning through learn.hashicorp.com. With that, I'm going to turn it back to you, Kelly, for any closing comments, and also open it for any questions here that anybody has pending that hasn't been answered by the TAs.
Perfect. Yeah, I'll go ahead and stop that recording so that